Hello everybody. All right, tonight's homework is just to watch this video and fill out your note sheet. And tomorrow in class, we'll work on the homework together. Okay, so starting with the always, sometimes, never problems, I'd actually like you at this point to pause the video and try these on your own. I want you to think about these on your own. And then when you think you're ready, come on back to the video. All right, so if two triangles are isosceles, then they are congruent. I say this is sometimes. And the reason that I say that sometimes is because I could have two isosceles triangles that are different shapes, right? That these are congruent and these are congruent, but it doesn't necessarily mean that they're congruent to each other. They could be, but they aren't absolutely always. Part B, if two triangles are equilateral, then they are congruent. Again, I think this is the same reason sometimes. I could have two equilateral triangles. How about one like that and one like that, right? Where these three are congruent. These three are congruent, but they aren't necessarily congruent to each other. Part C, if a triangle is equilateral, it is also equiangular. Well, this is always, right? If it's equilateral, well, then we know by our constructions that it's also equiangular, right? That constructs 60, 60, 60, right? Okay. Part D, if a triangle has two sides congruent, then it has two angles congruent. Right, that is sides imply angles. That's a theorem. If a triangle has two angles congruent, then it has two sides congruent. I think that is two angles congruent implies two sides congruent. And that's a theorem too. F, if a triangle has no sides congruent, then it has no angles congruent. So if it has no sides congruent, that makes it scalene, right? So did we have any examples of scalene triangles that were that had angles that were congruent? Well, if they had angles that were congruent, that would make it at least isosceles, wouldn't it? So if it definitely has no sides congruent, and then we can't have any angles congruent. Of course not. Okay, so I'm thinking no sides implies it's scalene, right? And scalene has no angles for sure. Because if it had congruent angles, then it would be at least isosceles, right? Wouldn't be scalene. So this is an always. And then last, in a triangle, the longest side is across from the smallest angle. No, that's a never. The longest side is across from that would be the largest angle. Okay, so that's a never. All right, I hope you did okay on those. Those can be tricky a little sometimes, so make sure that you take your time to think them through. All right, let's do some proof. First thing I'd like to do is when I look at the diagram, remember we thought we were looking at overlapping triangles. So I definitely do see some overlapping triangles potentially. I also see some bow tie triangles potentially. So I'm going to be thinking about some possible paths to take with my proof. I'm going to mark up my diagram first. Let's see, first given AD and BC congruent, an angle DAB and angle CBA. All right, I want to prove that angle ABE is isosceles. Well, right now I can prove that I think I see overlapping triangles. I think I see that this triangle here is overlapping with this triangle here. And those are using the given information, right? The side and the angle. So they have a reflexive side. So I think that's what I'm going to do. I'm going to do next that AB is congruent to BA, and that's reflexive. So now I can say that those two triangles are congruent. DAB congruent to CBA by side angle side, right? I got the side in step 1, I got the angle in step 2, and I got the other side in step 3. Okay, so where am I going to go from here? Remember that the goal is to say the triangle ABE is isosceles. This is what I want. I want to say that this triangle here is isosceles. So in order to say that that triangle is isosceles, I'm either going to need that I either need the base angles congruent to each other, or I need the sides congruent to each other. That's my goal. So I think I can get the base angles from CPCTC. Yep. I can get angle DBA congruent to angle CAB by CPCTC. Let's see this. Right? And those are the base angles of the blue triangle, which is the one we're trying to prove is isosceles. So I've got it. So I can say triangle ABE is isosceles. And here's my reasoning. Base angles congruent implies isosceles. I should be more consistent there. Isosceles triangle. Okay? Cool. All right, next proof. New color. All right, triangle OP and SR, KOKS. I don't know, there's a lot going on here. So I'm going to look at what I want to prove. I want to prove that MP, so I'm going to try and prove that is congruent to that. Now, what I notice from that is that those are sides of these smaller triangles, right? So I think if I was able to prove that those two triangles were congruent, that I'd be set, right? So let me see if I can kind of work backwards to that. Based on my givens, I'm going to mark up my diagram here and then I'll erase it once I sort of have a plan. So I know OP and SR, I know KO and KS. I know M is the midpoint, so that means that this would be congruent to this. And T is the midpoint, so this would be congruent to that. So how do I get one? Oh, cool. All right. So this is kind of creative, but look, I've got these two big segments, KO and KS congruent. I'm just going to give them some numbers just because I think when we work with actual numbers, it's a little bit easier to think of. Let's just say that this had a length of 10, and because these are congruent, that would also have a length of 10. If I have a midpoint and I divide that length of 10 in half, each of these would be 5, right? Well, on the other side, I also have a midpoint. So dividing that 10 in half, each of these is 5, which means that across all 4 of these segments that we get are now congruent. You see it? So this is a cool thing. This is actually called the division property. Right? What we just did. I took the whole piece and I divided it into half. And ultimately what we're saying is that halves of congruent segments are congruent. So let me say that again. Halves of congruent segments are congruent. Does that make sense? All right, this one doesn't come up very often, but it's cool when it does. All right, so then I think I can get across that MO is congruent to TS. So I'll ultimately have this. And I'll have this one. So I'll have those sides congruent. Be nice if I knew this angle was congruent to that angle. Oh, I do know that, because if sides, then angles. Okay, I got it. Here's my plan. That's a little messy. I'm going to get rid of it. But did you take a minute to think about the division property? I'll write it again in our proof, but all right, I'm going to clean this up. We'll start from scratch. All right. I'm going to start with OP, congruent to SR. It doesn't take me anywhere, but, you know, so since I don't actually get anything from that, I might as well list my other givens as well. M is a midpoint of OK, and T is a midpoint of KS. All right. Okay. I wonder, should I list KO and KS also? Let me do that. So I got everything. And that's a midpoint, and that's a midpoint. All right. So now I'm going to say that this is what's really, really neat about the division property, is that ultimately what I wanted, I didn't necessarily need to know this, that these two were congruent. That wasn't important to me. But what I said was that what I want to say is that these two are congruent. Remember the 10s and the 5s? We said all 4 of these segments would be congruent to each other. So using the division property, I can jump right to this. If I know that the wholes are congruent and I have midpoints, so I'm dividing it into half, I can go right to it. So I can go right to MO being congruent to TS, because halves of congruent segments are congruent. This is the division property. Okay. So just to pause that for a second, the division property we don't use very often because we could use subtraction property. Division is just repeated subtraction. So I could say, instead of using the division property, I could say, okay, I've got a midpoint, so I'm going to have these two congruent segments. I've got a midpoint, So I'm going to have these two congruent segments, right? And then I could subtract away segments from the congruent segments. It's just a little bit more complicated. It's more steps. So I like the division property. I think it's pretty fancy and fast, very efficient. So I'm going to go with that. But like I said, it doesn't come up very often. All right, so great. I'm at this point where I have two sides. Remember, and now I need the angle. And where did the angle come from? The angle came from the large triangle actually being isosceles, right? Seeing you've got sides. So if sides, then angles. So I've already said the sides. That was KO to KS. So I'm ready to say angle O is congruent to angle S if sides, then angles. So now the hard work is done. Triangle MPO is congruent to triangle TRS by side, angle, side. Let's see, I got my first side was in the givens. I got my angle in step 3, and I got my other side by the division property in step 2. Okay. So then I'm almost done. Remember, the goal was to say MP was congruent to TR by CBCDC. Ta-da! All right, we're almost done. One left. Okay, triangle ABC is isosceles with a vertex angle B. That's important to tell you what, if we say that this triangle is isosceles, it's important to tell us to say either which angle is the vertex angle or which side is the base, so that you understand what the orientation is, so you know which sides are congruent, which base angles are congruent. So ABC is isosceles with a vertex angle B. That's either going to tell us these sides are congruent, these angles are congruent. Triangle AFC is isosceles with base AC. So that means that this side is congruent to this side, and this angle is congruent to that angle. So I want to prove that triangle ADF is congruent to triangle CEF. All right, I'm going for the bow tie triangles. All right, how am I going to get there? Well, I currently have a side. I can do the vertical angles. So I've got angle, I've got a side. Oh, look at this. I can use the subtraction property. I've got the large angle congruent. I've got the smaller pieces congruent, which would mean the remaining pieces, the remaining angles would be congruent as well. So I could prove those two triangles are congruent by angle, side, angle. Okay, see the plan? Let's do it. I'm going to put that back in. I think that's helpful to see the two triangles. All right. So I think we're going to get similar information from both of these givens. So I'm going to list them together. So remember, I need to get the base angles. so that I can use the subtraction property. So I'm going to start with that. I'm going to say that angle BAC is congruent to angle BCA, and angle FAC is congruent to angle FCA. And the reason is that if these are isosceles triangles, that implies your base angles are congruent. All right, so I have this, and I have this. So from that, I'm going to draw the conclusion that angle DAF is congruent to angle ECF by the subtraction property. Right? Since we're talking about isosceles triangles, I'm just thinking about the flow of the proof. I know I'm going to get those vertical angles, but since we're talking about isosceles triangles, I also want to get these sides, right? I want to get these pieces in there. So I'm actually going to do that next, kind of for the flow of the proof. I'm going to say that AF is congruent to CF. And I have a couple of choices of how I want to say this. I could either say that isosceles triangle implies the sides are congruent, or I can say congruent angles, base angles implies sides are congruent. They're both good. It doesn't really matter. So I think because we just said that the angles are congruent, I think I'm going to go with that. Say if angles, then sides. But that's your call. All right, so now I need the vertical angles. Angle DFA and angle EFC are vertical angles. That's assumed from the diagram. So now they're congruent. Those vertical angles are congruent. And that's it. Now I got the triangles congruent. By angle, side, angle. See, I got my first angle in the subtraction property. So that was in step 3. I got my side in step 4. And then my vertical angles in step 6. Done. Okay, terrific. That's it. That's your homework for tonight. You watched the video and you filled out your note sheet. Tomorrow in class, we'll work in small groups to work on our homework problems. Okay, see you then.